We need to talk about chemical reaction rates for a minute. And so this video is going to talk about several factors that affect the speed of a chemical reaction. And the key to all this is that the particles in a chemical reaction have to be going fast enough and have opportunity to meet so that they can react. Think about star-crossed lovers, and if they never meet with each other, if they never bump into each other somewhere, they're never going to fall in love and get married and have a happy family. So one way to think of this is something called collision theory, where the particles have to have enough energy to crash into each other hard enough and with the right orientation. In other words, they have to be turned the right way in space in order to react. Because as you will learn later, particles have some sides that will not react, whereas the other side of the particle will react. Anyway, so a couple of factors that will cause chemical reactions to speed up are temperature. If you raise the temperature, then the rate of the reaction will increase because the particles are going to be moving faster when the temperature goes up. The surface area, if the surface area is increased, then the particles have more surface to touch each other on. That will also increase the rate of the reaction. Concentration of the chemicals. If the chemicals are more concentrated, then that means there's more particles per liter, let's say, if you're using liquids. There's more particles per liter. It's like having orange juice that's kind of watery, or tea or coffee that's kind of watery and it's not real strong. Or if it's supposed to be sweet but it's not very sweet, there's not as many particles of sugar in there per liter, so you don't get the same effect. So stronger concentrations will have the particles coming in contact with each other more often. There's a TED Ed video that I'm going to link you to on this. I think you should watch. Another thing that can that can speed up the reaction is a catalyst. And a catalyst is sometimes called an enzyme. And a catalyst can speed up the reaction by doing something called lowering the activation energy. So this picture shows chemical energy up the side and the progress of a chemical reaction across the bottom there. So as a chemical reaction occurs, a certain amount of energy is required in order to get the reaction to proceed forward. In other words, the amount of energy in the chemicals has to get up to here before it will naturally finish taking place. It's kind of like going up a ramp. Before you can go downhill, you got to get to the top of the hill. So it's kind of like a roller coaster. So what catalysts do is they will cause this hump to be lower. And so there's not as much energy needed to get the reaction started because a catalyst causes that hump to be lower. So activation energy is a minimum energy needed to get the reaction started. And one other thing I should mention is there's something called an inhibitor. And an inhibitor is the opposite of a catalyst. It gets in the way of a reaction and slows it down. That causes the chemicals not to be able to come in contact with each other the right way. I'll link to the TED Ed video, and I hope this helps.